Okay, so let's start. So hi everyone. This is a lecture that is quite different from the one you had probably in the past. Oh, so wait, can you hear me? I just okay. Sorry, I just had an interruption. Sorry for the delay. So today we're going to have a presentation which is quite different from you had probably during the past days, which is related to climate change. So if you're here in the interest of data science, well, welcome, but we won't talk about it much. Yeah. So I was giving a lecture about machine learning in healthcare actually a week ago, exactly a week ago. And I'm a postdoctoral fellow in machine learning and healthcare at the INRIA institution. And I'm also a deep learning instructor at a company called LvDS. But aside from that, I'm also a climate change passionate and a member of the Climate College Association that I'm going to talk about. And I'll give this presentation mainly within this scope. So a few words about the associations and what it is. Basically, the goal is to explain the complex, cleaving, and sometimes boring subjects of climate change in a playful yet rigorous way. And the whole idea of that is to have a game that you play in a collaboration between 4 to 8 people, and it's 3 hours of game and workshop. And so basically the association is merely everyone around the world. So if you're interested by that presentation, you can go further by contacting your local animator. I know there are some in Ukraine, as even deputy members had this game at the parliament. So let's start about a short introduction why presenting climate change. First, it's basically a growing topic and a major concern for many citizens around the world. But nevertheless, we're in a curious yet unsatisfactory situation where all of you probably know a lot of concepts, and that's why I ask you, what do you feel and what do you know about climate change? And you all had very different answers and point of view. So we all know a lot of different concepts, but in the same time, it appears, at least to me, that it's quite confusing to grasp and to understand the relations between all of that concepts. And so why such a situation? First, because we have to acknowledge that it's a very complex topic that we couldn't grasp talking with a friend at a bar in 10 minutes. It's way more complex than that, and we have to spend some time trying to understand what are the cause and consequences and definition of climate change. The other reason is that the people that talk about climate change are actually as confused as you may be, or at least as I was before. And those people that talk about it includes politics, NGOs, but also media. And it's often that there are some confusion in the way articles are written in the media. And the final but most important reason to that situation is we always have a small snapshot of what's going on, like a part of the whole picture, but we never have all of it in the same time to better have a mental idea of what climate change is and what it encompasses. So the direct consequence of such a confusion is that we act without awareness. We do things without knowing if they're useful or not. And the fact is, often they are not, and some of them are even counterproductive. So for all of this reason, we'll try to make climate change more clear. So I hope that will be clear for you within 1 hour, an hour and a half. So let's start by explaining and distinguishing ecology and climate change. I'll give you different examples of what ecology may be. So ecology may be water pollution, for instance. It can be also air pollution as well. but also the problem in the biodiversity is facing, the rising waters around the world, the wildfires, the pesticides, the soil pollution, and the waste. The first thing I'd like to mention is I'm actually lying to you when I'm showing some of the pictures here. The first lie I just showed you is the rising water. So actually it's not rising water. Those are floats. This is rising water, which are different, and we're going to explain what's the difference between both are. The second lie I shown on this presentation is the air pollution. So here on the top, you have nuclear power plants, and nuclear power plants doesn't pollute. What you see at the bottom of at the top of the columns is just water. But this is air pollution. This is an example of how polluted the air is in China, I guess. So as you don't see the skyline, people take picture of a fake skyline, a fake picture of the skyline. The third sort of lie is actually the biodiversity. So there are what we call umbrella species that gather all the attention, but actually the problem is not only for those umbrella species. It's basically for a lot of common species such as insects, butterflies, birds, etc. that are losing a lot of their representatives. And the final lie I showed is the soil pollution here. Actually, it's not polluted at all. It's a very well-known place in Iceland, which is very touristic because it's beautiful. So the first thing is, even by images that we see every time, we're kind of confused because the representations and the concepts they tackle are not the one they speak about. So you should be very, very careful when you see images, as they're often misleading. And so this is ecology, but among that, what is related to climate change? And this is actually a very important question. So if this potato is ecology, then climate change is only part of it. So let's start by what belongs to ecology, but what is not part of climate change. So all the type of different pollutions, as water pollution, soil pollution, air pollution, but also waste and pesticides, are usually not among climate change. They may have a tiny influence, but not at the order of magnitude we're interested in climate change. The other topic is biodiversity. Climate change is somehow related to it, as it has an impact on the biodiversity. But the first impact the biodiversity is facing is not related to climate change, but to the way humans artificialize the lands and use the biodiversity. So then what's included in climate change? So those are some of the examples of what's included in it. Wildfires were rising, but also global warming by 2 degrees in 2010. You've probably also heard, but there are a lot of different topics that we'll dig into. And I'd like to mention that it also includes the Paris Agreement that you may have heard about, but also fossil fuels and energy that we'll deal with, but also, last but not least, the relation between climate change and economy and GDP. So for the rest of the presentation, we're going to speak only about climate change. And to be honest, to me, ecology is too ideologically and politically biased to be discussed either here, but also in a general setting. If you talk about ecology, try to be precise about what you speak about. So now climate change. What is actually climate change? So I'm going to read the definition of climate change I found on the internet. Climate change refers to a change in a state of the climate that can be identified by changes in the mean and/or the variability of its properties, and that persists for an extended period, typically decades or longer. Climate change may be due to natural internal processes or external forcing, such as modulations of the solar cycles, volcanic eruptions, and persistent anthropogenic changes in the composition of the atmosphere or in land use. First, the typically decades or longer part of the sentence makes the climate very different from the weather. The climate is a tendency over time of what's getting higher or lower. Weather is just an approximation of what's going to be, what the weather is going to be like in 1 hour or 2, and for 1 day, no more. So those are very different. And this definition is actually the definition that is given by the IPCC, which is the International Panel on Climate Change. So I'm gonna briefly tell you a bit more about IPCC because it's a very important organ of the United Nations, created in 1888. And for the anecdote, it was actually almost led by the Reagan administration, which is not in favor of climate, but still he emphasized on creating this organ. And he has 3 working groups. The first working group of the IPCC assessed the scientific aspect of climate change. The second, the vulnerability of socioeconomic and natural systems. And the third, assessed the options to limit the greenhouse gas emissions. It's very important when you hear about the IPCC, which has different names in different languages, it does not produce science, but it analyzes it to produce reports, especially for policymakers. So in this presentation, we'll actually discuss a lot the conclusions of one of these reports, which is the 5th assessment report. It had 300 authors, 3 volumes of 1,500 pages each. And it actually reviews and analyzes in a sort of meta-analysis, almost 10,000 peer-reviewed articles, only for the work group 1, so for the 1/3 of all of its existence. So if you have to read one thing about climate change after the presentation or during your life, you can read the summary for a policymaker of the IPCC that was written in 2014. So once we've said that, we've actually not said much about climate change. We still don't know what the causes are and what the consequences are. So to do that, let's look at what's written in the IPCC and in the summary for policymakers. So the first working group has said that warming of the climate system is unequivocal, and since the 50s, many of the observed changes are unprecedented over decades to millennia. Then, atmospheric concentration of carbon dioxide, methane, and nitrous oxide have increased to level unprecedented in the last 800,000 years. And finally, human influence on the climate system is clear. It is extremely likely that human influence was the dominant cause of global warming between the 50s and now. And what the third working group has said is that without new policies to mitigate climate change, projections suggest an increase in global mean temperature of 3.7 to 4.8 degrees in 2100 relative to pre-industrial levels. And finally, the current trajectory of global greenhouse gas emission is not consistent with limiting global warming to below 1.5 or 2 degrees relative to pre-industrial levels. Okay, so those are a lot of different sentences, but the fact is that probably you don't understand all of it or don't know how to relate all of these sentences one with each other. For example, what are the observed changes that we talk about? What are carbon dioxide, methane, and nitrous oxide? Why are they so important? And how is that so clear that the human influence on the climate is clear? But also, what does it mean to have such an increase of the temperature? And what are the greenhouse gas emissions that we need to stop before having an increase of the temperature below 1.5 or 2 degrees? So actually, I'll try to describe in a larger picture what all those words and definitions are. So let's start by the beginning, human activities. Us as human everywhere around the world have basically very common activities or activities that rely upon our services or our usage of what we have around us. So among them, you have the transport, you have the industries, you have home and the way you use your home and your buildings by heating it, by using electricity, etc., and the food and agriculture. And what you have to understand is that anything you use or which is around you, as the computer you use to watch me, or the table your computer is on, or the chair you're on, or the bed you're lying in, anything has used energy to be done. So everything uses energy. Even the food that is in your fridge has used some type of energy to grow, to transport, etc. And this energy actually is made or is created, is converted from fossil fuels. So we use fossil fuels to have our energy. And those fossil fuels are threefold. The first one is the oil. The second one is the gas. And the third one is the coal. And the problem of all that fossil fuels, the key problem is that they all emit what we call greenhouse gases, such as the carbon dioxide. There are actually two more greenhouse gases that we're interested in that are released by agriculture in a different way, which is methane and nitrous oxide. We said now you have the first picture going from human activities and us as human to the release through fossil fuels of greenhouse gases. That's the first thing to understand. Then, why are those greenhouse gases so important? First, greenhouse effect. I have to say what it is. It's basically a natural effect that exists on Earth, no matter if humans are here or not, that kind of holds the energy that is received from the sun to keep the temperature warm in the atmosphere and at the surface of the planet. Without the greenhouse effect, no life on Earth. It's going to be like minus 11 degrees on average, but it's almost impossible to live without such effect. And the first misconception I'd like to tackle is the way this greenhouse effect is represented in the media or in different figures. This is probably what you see. There are some solar radiations, they are entering our atmosphere, some go back into the atmosphere and are reflected and are stopped. The problem with such presentation is that the first question you would ask yourself is why are the solar radiation entering the atmosphere but not getting out? This is something weird, right? And the problem is that this representation is misleading. What happens really is that there's a visible light in yellow here that is entering our atmosphere. Part is reflected, but the biggest part is absorbed by the surface. And for the one that are interested about physics, once a body has a certain temperature, a black body, it emits some radiation. And our Earth, instead of emitting visible light, it emits infrared waves and radiations, which are here in red, and which are very different from the one entering. Here is visible light and here infrared radiation. And those infrared radiations are actually the ones that are stopped by greenhouse gases. So greenhouse gas, the definition of a green gas house is no more than a gas that stops or absorbs the infrared radiations, which are then held in the atmosphere. And so basically, the more greenhouse gases we have in the atmosphere, the more energy we store in the atmosphere without releasing it in space. And this is why greenhouse gases are so important. The more we have here, and the more energy we keep in the atmosphere. So I've presented some of those gases. The first one that we speak about a lot is the carbon dioxide. The second one is the methane. The third one is the nitrous oxide. But I will let you 10 seconds to guess what is the most important greenhouse gas that we have in the atmosphere. So basically, the gas that is responsible for more than 50 up to 60% and even more of the whole greenhouse effect is the water vapor. It's way more important than carbon dioxide. However, why don't we talk about water vapor? If you make your water boil, aren't you augmenting and increasing the greenhouse effect? So basically no, because the amount of water in the atmosphere is an exact equilibrium between atmosphere and the oceans and water, fluid water. So if you're boiling some water in your kitchen, there's somewhere raining the same amount of vapor of water. So basically, it's not that obvious to increase the number of water in the atmosphere. That's why we don't talk about it when we speak about greenhouse gases. However, in the other case, carbon dioxide, methane, and nitrous oxide, when you release them in the atmosphere, they are stored somehow in the atmosphere, and there is no natural, physical, or chemical process to clean and to wipe those gases from the atmosphere. And so this is very important. The greenhouse gases, except for the water vapor, all the other ones, once emitted in the atmosphere, are left in the atmosphere, at least for a long period of time. And this is actually the problem. And it leads to three very important points. The first is that as they have different residence time, so the time they are in the atmosphere, you cannot compare them directly. You have to compare them depending on the period of time you consider, because they are not removed and cleaned from the atmosphere at the same pace. But the two key points, the first is that as there's no cleaning, the temperature in the next 15 to 20 years is almost entirely dictated by our previous emissions. The atmosphere doesn't care about how much we emit per year. It cares about how many greenhouse gases there are in the atmosphere, no matter when they were released. And so the direct implication and correlation of that is that the goal is not to stabilize our emission per year, but to make them equal to zero. Because once they're equal to zero, then the total amount in the atmosphere remains stable. And this is very important to understand. We have to have our emissions being equal to zero, or at least the emission have to be the same as the one we can take out of the atmosphere thanks to different things. Okay, so now we've seen, so first that human activity leads to greenhouse gases. Then these greenhouse gases lead to the warming of the atmosphere. And now let's see if only those greenhouse gases are the only source of warming. So how to read this figure? Each line is a component that either hits the planet if it's on the right side of the black arrow line, or cools the planet. And the magnitude here is the amount of heat of the given line. So the bigger, the most important component of climate change, of global warming and of this warming, is actually the CO2 we talked about. The second one is the methane. And the other one, the nitrous oxide, is right here. You've probably heard about the fact that some people believe that solar cycles actually change the amount of energy they are at within the atmosphere. And so those variations are responsible only for this little part here. So it's 100, there's an order of magnitude of 100 between the cycles of the solar system, of the sun, sorry, and the effect of the CO2 we emit. Then there are also counterpart. There are other factors and processes that makes the planet cooler. One of them you've probably heard of is the albedo effect. which is the reflection by surfaces, and especially white surfaces. So the Arctic and the Antarctic, as they're white, they reflect before absorbing the heat, they reflect the visible light through space. And this is a good thing. But I'll just add that this is probably one of the first feedback that you'll see. The warmer it is on Earth, the less white surfaces we have, so the less reflection we have, so the more heat we keep, so the more ice is melting, so the less white surface we have, so the more, and so this is a loop that kind of like increases itself the amount of energy we keep on Earth. And this is only one of it. And the second big thing here, which cools the planet, are the aerosol. And those are basically all the small particles that are not heavy enough to fall on ground. This is like all the sand and mineral dust. And you know where this dust may come from, at least not for all the time, but some of them are coming from volcano. So if you have a volcano blowing up somewhere on the planet, you'll have some sort of, those are not clouds, those are aerosols, but that will prevent the light, visible light, from entering the atmosphere. And thus you'll have less energy in your system. So here, after I just explained why the greenhouse gases are the first reason of our global warming, and they're released by humans, here are actually the different signature and kind of proofs or correlations of this climate change. And those are also the first order consequences, the first one we can look at. And so here, the first numbers are actually the sources to those figures in the summary for policymakers of the IPCC 2014 report. So here's the rise of the CO2 emissions. There's a yearly variability, which is actually caused by the fact, which is actually caused by the photosynthesis of the trees that are have a larger number on the north hemisphere. So there's less carbon dioxide where it's not fall, but summer in the north hemisphere, and more where it's winter in the north hemisphere. The other signature and consequences we have is the rise of the temperature from 1850, which is the start of the pre-industrial, the industrial era. And from this time on, we started to use massively fossil fuels. And so this is the increase of temperature over the last decades. This is also the increase of the temperature in the ocean. Another thing is the ocean heat. So this is the power, the energy that is stored within the ocean. Here is the ice extent. So basically the ice is melting everywhere around Earth. Those are only observations. Those are not predictions. Everything you see are observations. And the rising of the sea level as well, as if you have ice melting, you have the rising of the sea level. So those are more of climatic consequences. Nonetheless, what you can have is consequences of these consequences. This I would call second order consequences. The first one are, for instance, wildfires that you've probably heard of in Australia, in Russia, Siberia, also in Brazil. You have the glacier melting, you also have flood, you have droughts, you have heat waves, you have starvation, migration, conflicts, etc. And so, as I told you, there's a difference between a flood and a water rising. Water rising is the sea level or the ocean level rising, whereas flood is made by rains, too many important rain in part of the planet. The other difference is the difference between drought and heat waves. Drought is not enough water, whereas heat wave is too much temperature. And from that, what I'd like to stress is that the uncertainty in the prediction of such consequences, we're not able to predict where is going to be immigration, nor when. And such uncertainty in the prediction does not mean that they are nor severe nor very likely to appear. And it is very important to keep in mind. Those are being able to predict that one is going to occur and one is different from saying that they will occur and their pace will get higher. So from all of that, I'm going to briefly summarize everything that has been said for you to have a clear picture of all of what climate change is from the beginning to the end. Human activities are, among others, agriculture, industry, transport, and building usage. You can almost include everything you do or businesses and industries do within those four categories. Altogether, they need energy, and by needing energy, they release through fossil fuels greenhouse gases. The three important ones are the CO2, the nitrous oxide, and the methane. Those greenhouse gases, they will add an additional greenhouse effect, whose implication is that more energy will be kept within the atmosphere and within this planet Earth system. So we have more energy that is kept in the atmosphere. Those will have first order effect, such as the rising of the air temperature, the rising of the water temperature, the melting of the sea ice, the melting of the glaciers, and the melting of the ice sheets. Those will have second order temperatures, such as the river flooding, the marine submersions, the cyclones, the droughts, etc., etc. And all of that are vectors or will stress problematic situations that already exist, but they will emphasize and stress them. And it might lead to famines, climate refugees, it can be a vector of diseases, problems for the human health, and conflicts. And on top of that, you have feedback loops that are said to be positive, as once they are here, they augment and they increase the problem. So I'll leave you with a few, no, it's not the end, but I'll ask you and let you a few seconds to think about any of the questions I'll ask here. So according to you, what percentage of farmlands and basically of crops is used only to feed animals? So from all the food we are growing, what percentage is used to feed not humans, but animals? So it's 70%. So 70% of all the fields you see around you when you're in the countryside of your country are used to feed animals. And it's very funny because, for instance, in France, there's a lot of cornfields, whereas no one's eating corn in France. So no one's wondering why there's so many corns, like is there a secret organization eating so much corn? No, it's just because we're feeding animals with this corn. And the same goes with sunflower, no, it's not exactly true, forget about it. Then, as I told you, we're emitting greenhouse gases. The most important one is the CO2 gas. According to you, where does this gas go? It goes to different location of the Earth system. Which one are they? And according to you, to what percentage of the gas goes in each part? So as we know, part is going in the atmosphere, but it's only 50%. 25% of the CO2 actually goes within the ocean and makes the oceans acid, which is a problem for the biodiversity, but part of the CO2 goes in the oceans. The third, what we call sink, a CO2 sink, is the photosynthesis. So basically the trees that are growing around the world. And 25% of the CO2, of the carbon, goes within the trees that are growing. Third question, according to you, where does the heat and energy goes? So we first have greenhouse gases that stores or holds or keep the energy within the Earth system. Where does this energy goes? So obviously part goes in the atmosphere as we have the global warming that we've discussed earlier. But this is actually a very, very small percent of all the heat. 1% of all the heat we're keeping on Earth goes within the atmosphere. So once someone speaks about the fact that the temperature will increase by 2 degrees by the end of the century, those 2 degrees only represent 1% of all the energy that is coming and stored on the system Earth. 3% is melting ice, either sea ice, glaciers, or ice sheets. 3 goes in the soil, and 93%, like most of it, is going within the oceans and also the seas, but mainly in the oceans. This is a very interesting one, which makes you understand what +2 degree means. So according to you, so a long time ago, at the last ice age, the oceans were 120 meters below their actual level. And so all this water that was removed in the oceans was somewhere, and the somewhere means the form of ice. And Paris was basically under 3 kilometers of ice. So would you guess what's the difference in temperature between this ice age and now? The mean between two means. So to have such a state, such a planet with 120 meters less water and Paris under 3 kilometers of ice, but a lot of cities and continents as well, it was only 5 degrees less. So it doesn't seem a lot. And finally, according to you and what you've heard or seen, what's the forecast of water rising in the 21st century, or the 22nd century, actually? In meters, centimeters, decimeters, whatever. So it's not that much. It has a lot of consequences, but it's 40 to 80 centimeters, less than a meter. And probably those of you that thought about 2, 3, 4, 10, 15 meters, there might be two reasons. The first one is that the pictures that are shown in the media or different places are not pictures of water rising, but of floods, which makes our mental representation false. So some figures about all I've just described. Here, we've spoken a lot about the greenhouse gases, but let's look at their distribution and what we release per year. So this is the amount of greenhouse gases we emit in the last 40 years up to 2010. Now it's even more. It's only getting bigger and bigger. And so most of it, 65%, is due to the CO2 that we emit from the fossil fuels and the industrial processes. 11% is also CO2, but it's not due to fossil fuels, but it's due to the forest and other land usage. So how, when you want to transform a forest into a crop to grow some vegetables, for instance, what you do is you tear down the forest and all the trees. And if you want to if you want to remove them, you have to burn them. But as a tree is a sink of carbon, once you burn the tree, you just release all the carbons that's in it within the atmosphere back. And so this explains those 11%. So this is due to agriculture. Here we have the methane, and here we have the nitrous oxide. Yeah, and just a quick word. Now we're in 2020, and we have a goal to meet, which is the Paris Agreement that I'll talk a bit later. And this Paris Agreement sets a goal for 2050. And we have to reduce our emissions by 2050. And so the amount of reduction we have to do every single year is 5%. So this year we have to reduce by 5%. Next year we have to reduce by 5%, etc., etc. And just that you have an order of magnitude, the forecast for this year, in the presence of pandemic that stops a huge part of the industry, is supposed to decrease the amount of greenhouse gases emission by 5%. So we would need one more pandemic per year to meet the Paris Agreement. That just to tell you how hard the task is. Where does those greenhouse gases come from? Especially, so here's only the CO2. It's a focus on the CO2 and where it comes from in the world by economic sector. So the first sector is the production of electricity and heat in orange here. So to produce electricity and heat, we mainly use gas, oil, and coal to produce it, and those fossil fuels release a lot of CO2. Then in green, 25%, almost 25% is the agriculture and the FOLU, so the forest and other land usage, which is responsible for a quarter of all our emissions. The industry, 21%, and the 14 here, which is the transport. You may have seen a slight different numbers. It sometimes depends where you include some activities. Some activities where it may be part of industry or transport, and depending on how you count them and how you include them, you can have slightly different numbers, but the orders and the ordering is always the same. But instead of looking at that by economic sector, let's look at that by country. Which country is emitting the most? So this is representation by Our World in Data, which is a very good site. I'll stress, you can look at what they're doing. They have very beautiful visualization. And what you see, the big square is the total amount of CO2 emissions, and which smaller square is a country and the amount of CO2 it emits. So Ukraine, for most of you, is right here. China is definitely the bigger one here, followed by the USA in green, and the European Union, Russia, etc. And this is international aviation here, which goes from 2 to 3.2%, depending on how you count it. And it's outside of all the other countries because international aviation is not in the inventory, in the national inventory or of any country. It's decided to be a part of it. And so instead of looking at that in this way, what about, so from that figure, we can incriminate China, the US, and European Union to be part of the most part of the CO2 emissions. Nonetheless, it's important to, as to me, as what I believe, to say that every human is equal. And so what we have to look at is not the total emission, but the emission per capita within each country. So you divide this number by the number of persons within each country. And what you obtain is very different from what you just saw. So here, China is not the first country anymore. The US, Canada, and Australia are ahead of it, such as Saudi Arabia and South Africa. Nonetheless, those representations are again a bit misleading. And the reason is that here is the emission within each country. However, it's maybe not what you want to look at, because in China, for instance, a lot of the emissions are not produced and emitted for Chinese people. They are emitted to be exported around the world. So what's interesting to look at is not the emission, but what we call the consumption or the footprint. This is basically the amount of CO2 responsible for your national emission, plus the one that were emitted due to the importation, minus the exportation. And so this is more interesting. It actually computes the amount of CO2 that each person in each country is responsible for. It's a footprint. And this is how it looks like. And so here, we've only represented the CO2, only the CO2, not the two other greenhouse gases, which are the methane and the nitrous oxide. And so to kind of compare them and understand with only one metric, we convert all those greenhouse gases into what's called CO2 equivalent. And so to do that, to know the amount of CO2 equivalent you're responsible for, just take your country. So for instance, I live in France right now. And so on this map, it's at 7, the amount of consumption-based CO2 emissions. To have the equivalent by including methane and nitrous oxide, I'll have to add roughly 30 to 50%. So that means, and that's a figure I know of, France is, each person in France is responsible for 10 to 11 tons equivalent of CO2 per person. So we go from 7 to 11. And so what the Paris Agreement tells us is that instead of polluting, like here, 12 tons per year per person, we have to be at 2 tons per year per capita of equivalent CO2. So basically, a French citizen has to reduce his or her amount of CO2 equivalent emissions by 6 within the next 30 years, which is a very short time frame. And this is to meet the Paris Agreement, to be below 2 degrees. Okay, now that we've said that, let's try to dig into the causes of those greenhouse gases and trying to understand where they come from so that we're able to tackle the issue. And so basically, the greenhouse gases, as I told you, are just the product of a co-product of the energy we are transforming and using. So where does it come from? Every time you are doing an activity or anything that surrounds you has been created or developed or in an industry or even the services you are using, everything around you has needed some form of energy. And this energy that you need is called the final energy. This is the one you use. So for instance, the electricity that runs through your computer, or the oil that you put in your car or in your plane, or the biomass that you burn to have a fire and to cook, or the waste that you also burn in a lot of countries, etc. But this final energy comes from a source of primary energy. So for instance, electricity itself, which is a final energy, may come from different source of primary energy. Electricity is produced by coal, 40%, by natural gas, 20%, by hydropower, 16%, nuclear, 11%. The solar, wind, geothermal, and biomass altogether represent 6%, and oil is only 4% of the total amount of electricity. So for each final energy, you have a type of primary energy. And those primary energy we're using are oil, 32%, coal, 27%, gas, 22%. So this line is the fossil fuel, and it represents more than 70% of all the energy that we're using. And the rest, 10%, is biofuels and waste. Nuclear energy is only 5%. It's a huge problem everywhere that we hear a lot, but it's only 5% of the entire number of energy. The hydropower is 2.5%, and the renewable, including wind and solar, are less than 2%. And so let's look at how they evolved through time. So this is the pre-industrial area. This is the beginning of the industrial area with the beginning of the coal usage in Britain, a bit later on in Europe also. Then crude oil with John Rockefeller that started to the Standard Oil Company, natural gas, and now the renewable energies. It's very important to understand also that those energies were the first one we were using in meals and traditional biofuels as well. So it's basically burning forest and wood to have some type of energy to cook, for instance. And anywhere you cut your graph at any age, if you look at the pie chart, we've always seen from 70 to 80, 85% of all the energy we need coming from fossil fuels. It has never decreased, nothing, like 70 to 75%, the one that we have to stop. So we have to replace 75, 70% of all the energy we're using by something that does not emit CO2, carbon dioxide. So here I'll sketch a few facts and beliefs or a misrepresentation and misunderstanding we have so that you have a better understanding of the energy we're talking about and the problems that they may face. First, there's a common misrepresentation is the energy is not the electricity. Electricity is part of the energy, but it's only roughly 20% of it. So when you say that you will replace some type of electricity by a renewable energy, you are just changing part of the electricity, not of the energy, right? The second thing, which is a very good intellectual defense, is the rebound effect. So basically, the rebound effect states that once you improve, once you optimize any type of consumption, if you look at the total number of consumption, it's not getting lower. And the reason is that when you optimize something, you just augment the number of units of your something. For instance, our phones have a way better battery than 10 years ago, but the smartphones are now more energy intensive than 10 years ago, making our battery way less longer than 10 years ago. The same applies to cars. Cars are way more efficient than 15 years ago, or 50 or 40, whatever. Nonetheless, the number of cars increased way more than in efficiency, making it in total more of a problem than before. Same applies to plane, same applies to almost anything. When you optimize something, it leads to using more of the thing. Also, and this is a consequence or something you see from the previous figure, we have never replaced the energy. We just stack them. So as our energy consumption grows years after years for the last 150 years, we've never been able to say, okay, let's take some oil, electricity is produced by oil or by coal, and replace it by renewable energy. We just stack them. So for instance, in China, where there's a lot of renewable energy growing up, like solar panels, they are not used to replace the previous coal power plants. They just use so that the new electricity, the new demand of electricity is tackled by those sources of energy. And as I told you before, again, the goal is not to stabilize or reduce our emissions, but to emit as much as we can store. So basically, every year, the trees that are growing can store a small amount of CO2 emissions, and this is the exact figure we have the right to emit. We have we can emit as much as different things around the world can store, which is not a lot. And so we have to be at this zero equilibrium by 2050. Other facts and beliefs that are related to different sort of energy. Fossil fuels first. There's also a misrepresentation between what is said about the reserves, the amount of fossil fuels that they are in the ground, and the fact that we will stop them because they are not enough. The problem is that yet there is not enough, and there will be an end to that sometime, but it's not the problem climate change is facing. Climate change, in order to tackle this problem, we have to stop using them before the end of the reserves. There are enough coal in the ground around the world to produce a bigger catastrophe than just the end of the reserves. And among the three first coal miners and the one that have, among the 10 top coal reserves that are around the world, there's the United States, I kind of don't care, China also, and Russia, and Australia, Kazakhstan, Germany, Poland, and Ukraine. And so if we want to tackle this problem, we have, as an international citizens, have to ask all of these countries to keep their mines and their coal and their oil in the ground, which is actually something hard to ask, but this is something we need to do. I don't know which way. I'm not saying there's a good way or not, but this is something we have to keep in mind. Also, when talking about wind and solar, as I told you, it's a very small part of all the energy. It's less than 2%. It's 1.2, I guess, just for the wind and solar. Those type of energy cannot be compared directly to fossil fuels and nuclear. And the reason is that they're intermittent, meaning that when you don't have sun, you don't have energy. When you don't have wind, you don't have energy. And so they could require either a storage infrastructure, we don't know yet how to handle, or an alternative energy. So in Germany, when they don't have any wind nor sun, they ask for their neighbors to give them some energy as they're intermittent. So it's very hard to rely only on intermittent energy. And it's not possible, it's not feasible to compare them right away. Also, wind and solar, aside from climate change, have other ecological damages that are not included in climate change, but are some type of pollutions that are due to the fact that those type of energy are very complex and they need what's called a rare earth element. And where they are digged around the world, they imply, due to low ecological standards, they imply some different sorts of pollutions. So whether either water pollution, air pollution, or soil pollution, which is not exactly related to climate change. Finally, as for the nuclear question, nuclear has one of the lowest ratio of CO2 emission per kilowatt, so unit of energy. So nuclear may have some disadvantages that are not related to climate change, but within the kind of climate change, nuclear energy has one of the lowest ratio of CO2 emission. So it's, as for the climate, a good thing, or at least better than fossil fuels and wind and solar if we have it installed. And also, if you talk or if you hear about nuclear, even though it has some problems and it's dangerous, and you probably all know about it, there has been 3 major incidents in the history of the world with the nuclear energy. It should be understood, or at least nuclear should be considered not by itself as being dangerous, but relatively to the other type of dangerousness of the other energy types. So for instance, the coal that is used to create some electricity around the world kills yearly more people that nuclear has ever done for the last 100 years. So there is no best option to us. I'm not saying that nuclear is the best, nor wind and solar is the best, nor fossil fuel is the best. They all have some problems that are related to climate change or other type of ecological problems. But what we have to choose is some sort of a compromise between advantages and disadvantages. And now let's think about energy that we so much talked about. What is actually energy in itself? Energy, if we want, can be summed up as the quantity. It quantifies, the energy quantifies an amount of transformation. If you want to transform one state of something to another state, you need an energy. And you quantify this quantity with energy. You just a sort of a metric. But there's actually a second metric that exactly quantify an amount in transformation. And this quantity, this metric, is the GDP. The GDP is basically the amount of money that circulates within an economy. And so both, either energy or dollars in the case of GDP, both quantify an amount in transformation, largely speaking, for most of the cases. So the more expensive something is, the more energy has been inputted to have the transformation. So those are basically two different metrics for the same thing. So I'm sure you are not convinced by that, but let me give you some proof or examples and figures to prove that. First, let's for each country plot the amount of energy it uses per year and its per capita GDP. And this is what you have, an almost linear line. And so the scale here is a log scale, be careful, here also. But basically what it says is that the less energy you use, the less GDP you have per capita. The more energy you use, the more GDP per capita you have. And so as for now, we yet don't know how to grow economically without growing energetically, and thus without emitting CO2. Because again, energy is the counterpart, the CO2 is the counterpart of energy. I know this is hard to grasp, so if some of you are still not convinced, let me convince you in a different way. Yearly, we can count the world GDP. And we can also count the world energy consumption. And we can also count the world CO2 emission. And so if we represent on a graph year after year the evolution of one against the other, this is what we'll have. This is the world GDP against the greenhouse gas emission. And this is the GDP against the primary energy production. So each dot is a year, and year after year, we report the world GDP and the greenhouse emissions, or the GDP and the primary energy production. So this is kind of a final joke to finish with, but this is to me one of the best microeconomic models so far. I mean, you need only one variable to understand how the world GDP is growing. So this year, due to the coronavirus, we'll have less primary energy used and a smaller world GDP. These are just two sides of the same medal. And so again, if we have to think about making our greenhouse gases emission reduce, it means that somehow we'll need to reduce the GDP, or that we'll have to find another way to keep the GDP the same. But this is a very tough question to answer. And also, it also means that politically, it's somehow hard to say that as a political leader, your GDP will grow by 2%, where your greenhouse gases will decrease by 5%. Because as for now, we don't have any proof that it's feasible. Or if you think that it's feasible, if you state so, you have to state how you do that, because it goes against whatever we've seen in the past. And it's very important. So solutions, you probably, well, after what I've said, you probably started to understand what are the possible solutions so far, and what we have to do and what we can't do and what's working or not. But I'll let you actually find the solution by yourself by playing a little game. This game is derives from the Kaya equation. So what does this equation tell us? You have the CO2. Well, I think you, as you're all at the summer school, you are all aware that CO2 is equal CO2. This is allowed. And we can divide and multiply the CO2 on the right by the same amount, which here will be the energy that we use on the planet. And then we'll do the same with the GDP. And again, the same with the number of inhabitants. And this equation is always true as none of the denominators are equal to 0. So this is perfectly valid. Now let's look at all of the terms of the multiplication and what they mean. The first one is the CO2 emission intensity of energy. So how many molecules or amount of CO2 you emit when you use a unit of energy. For instance, for an amount of energy of coal, you emit a lot of CO2. For nuclear, you emit way less. Here is the amount of energy for 1 point of GDP. So as I showed you earlier, there's a strong relation between both. And when you want 1 point more GDP, you have to increase your energy by to some extent. Because this is almost the coefficient of the linear regression I've shown you earlier. This is just the GDP per habitant, so the amount of money that every person on the planet earns. And finally, here is the number of inhabitants around the world. And so this is where the game starts. You are the ruler of the planet. You can decide whether you are a dictator or not. It doesn't matter. But the task you have is to reduce the left term by 3. So you have to divide this number by 3. And as you want this equation to still be valid, you have to have this vector somewhere here. So you have to divide each term by a given quantity so that the multiplications of all these quantities are equal to 3. So one option is to decrease the number of inhabitants by 3. I don't see it coming in a political manner. The second option is to decrease the GDP per habitant by 3. So let's take your average income right now and divide it by 3, and you'll tell me if you're okay with that. Then you can divide that by 3, but again, we don't know yet how to do that. This is the linear plot I've showed you. The amount of energy per GDP has remained the same for the last 100 years. We don't know yet how to decouple it. And this, the CO2 per energy, is basically the amount of CO2 you have per energy, and this is more of to scientists to do, or to replace fossil fuels by something, but we have to decide what. Because if you want to make your plane fly, well, you cannot replace fossil fuels as easily as you want. I can give you 2 seconds to thought about that, but how would you have the 3 affecting the 4 factors to reduce your CO2 emission by 3? Well, if you're interested by that, the Ki equation has a lot of sources around on the internet that you can check. Finally, I'd like to make a point at what you can do at the individual level by telling you what are the activities that contribute the most in general in your carbon footprint. And this is what you want to reduce. Transportation is responsible for almost 25% of your carbon footprint. Food, and mainly meat, is responsible for 20% of your carbon footprint. The usage of your building, which means mainly heating the building and the house or the flat you're living in, and the electricity used are responsible for an amount of approximately 1/5 of your carbon footprint. And there are 2 things that I'd like you to keep in mind for the future, as they might be very important in the things you can do at your individual level. The first one is the money and the savings. So it might be weird, but some of you might have some money and savings on a bank account, and this money is actually not sleeping on your bank account. Your bank, usually depending on what type of account you have, but your bank can use this money to fund another type of any other debt. And by doing that, it's using your money, not all of it, and the mechanisms are way more complex, but there is still some sort of relations between the money that is on within the bank and the money it can fund to different things. And so you can ask your bank what is done with the money you're lending them, that you know what kind of where your money is invested into. And this is something people can do. And depending on what type of projects is funded, you can take your money out and put it in another bank. And it actually works, and it scares bankers a lot. The fifth option is voting. So I'm not saying this is for you to know if climate change is one of the major problems or not. This is your personal decision. Nonetheless, once every 3, 4, 5, 6, or 7 years, depending on the country you're working in, the voting process is a way to have people that represent your beliefs. So if climate change is one of them, if not the most important one, you can rely on this voting to make people represent you and people that speak about it and think about it. But I'd like to add that this amount are very, very, very different from one person to the other, depending on the country. So because in different countries, the amount of CO2 in the electricity is very different. It's one of the lowest one in France, thanks to nuclear power plants. So I know that for myself, the electricity doesn't play a big role in that. But it also depends on your individual actions, either you eat a lot of meat or not, either you use planes or not, etc. So for that, and if you want, this is not for me to say if you have to, but if you're interested in acting, or if you already do, don't do that in a way that would be a waste of your personal energy. You have to do something that is useful. Don't do something that represents only 1.1% of your total carbon footprint. Not because it's bad, but because you'll waste a lot of your personal energy into something that is less useful than other thing might be. So for that reason, I would suggest you, there are a lot of carbon footprints online, on the internet, everywhere, and do your personal carbon footprint to know what is the amount of CO2 emissions that you're emitting as a person. Be aware that those carbon footprints might differ from one country to the other, and from one calculator to the other, they rely on different assumptions. But so if you do 3 or 4 of them, you'll have a good picture, a statistical mean of your footprint. And I'll finish by something. Never forget that your individual actions do have an impact. I'm not saying that it's a bigger impact, but it's wrong to say that it doesn't have any. The reason is threefold. The first reason is that businesses and industry emissions are driven by individuals. Business and industry is just part of our individual life. Without any individuals, no business nor industry. Businesses and industry are just a way to serve our desires in some way. The second reason is if you don't care, or if you think that it's too late to do anything because we won't do anything, this can happen. But if you think that, I would suggest you to act not for the society or the people around you, but for yourself, and to kind of get prepared. Because if, I don't know, for instance, you live by 20 kilometers, there's 20 kilometers between where you work and where you live. If the price of the oil get 3 or 4 times higher within the 10 next year, you maybe don't want to do this 10 or 20 kilometers walking. So these are kind of the thing you can think of if you want to get prepared yourself for life not too hard without fossil fuels. And this thought can be also taken at not only the individual level, but a family level, friends level, city level, region level, but also country level. And so some countries are not emitting a lot of CO2. And this is, to me, not a good reason not to prepare, because if, let's take France, which is responsible for 2% of all the worldwide emissions, which is not a lot, and a lot of people are saying, well, it's not a lot, so why should we do anything? The reason is that even if you don't do anything, you're not prepared, and you still rely on those fossil fuels. And so you are dependent on other countries or institutions around the world. Basically, you are 100% dependent on the fossil fuels from the Middle East and from the oil. So if there's a problem, there has been many wars there might be other in the future, or if we diminish or decrease the number of fossil fuels we're using from the Middle East, even if it's not a big amount, we better use as few as possible as a country. And finally, the third reason is that humans are mimetic. And what we do is basically nothing more than what others are doing in different countries or in family, etc. So if you start doing, others will follow. And this has been proven in a lot of papers related to climate change. If you say to a friend that you don't take a plane for any reason, it has the impact that 3 persons or 4 around you will change their mind about their future vacations and where they will go and whether they will take the plane or not. So to conclude this lecture, a few takeaways. You can forget about everything you've just heard. Just remember maybe this last slide. Ecology is not climate change. Climate change is a part of ecology, as biodiversity is part of ecology, as pollution is part of ecology, as water or the reserves of water are part of the ecology. And so ecology is not a metric, it's a compromise between all of that. So once you have all of these parts, you have to make a choice. And this choice might be good for the climate, but bad for the biodiversity. And one of the very good examples of that is the electric vehicle. So self-driving cars, but electric cars. They're good for the climate only if the electricity has less CO2 per energy than the oil, which is not the case in every country. But it's not good for the pollution it is responsible of due to the materials that within it. But on the same side, it's good for the health. It has less particles than oil cars. So ecology is not a metric, and this is very, very important to understand. You cannot say that something is more ecological than something else. Something emits less CO2, has less impact on biodiversity, makes more pollution. And at the end, you have to make a choice, a personal choice, or as a community. And this choice is a compromise between all of that's metric. Second point, this is the flow that we're responsible for and that causes climate change. The human activities need fossil fuels to produce some energy. The usage of these fossil fuels emits greenhouse gases. And those gases are responsible for the heat retention within the atmosphere. And this increase of heat that there is in the planet system is responsible for the climate change. And this climate change has first-order consequences on the climate and second-order consequences on biodiversity and people as us. Third point, there's a strong relation between greenhouse gases emission, energy, and GDP. They are all linked together. Or if they're not linked, they are correlated one with each other, and we don't know yet how to decorrelate them. Fourth, which is a sum up of all we've said, changing to the level needed and that we agreed on through the Paris Agreement, these changes imply to change our economy and society structurally. Not just changing our daily life, it's really changing things structurally. The distance from home to where you work, the amount of time you spend on vacation, not the amount, but the distance to your vacation, the food you eat, the way you heat yourself, etc. And this is the changes that we have to make if we want to meet the Paris Agreement. And so this is it. Thanks for listening, because it was not at all part of the data science summer school. So if you're still here, thanks. I hope it was interesting. If you have any questions or comment, or if you want to have more sources or you're interested by that, two options. The first one, reach me. You can send an email. I'll be happy to answer and provide a lot of documentation. There is a lot, and the hardest thing is to grasp and to find this information around in the internet. So I can send some links if you're interested. And the second one, if you want to go a bit further, or at least have a game within 3 hours, reach out your local animators for the Climate College Association. Thanks. Okay, so I'll just look at the questions. Actually, wait for some minutes. Yeah, so starting by the questions. How much cryptocurrency has influenced climate change? Impact of data centers and higher parallel computing doesn't matter. This is a very interesting question, a very, very tough one. And that has many good things and bad things. So as for I have heard of no any study whatsoever that looks carefully at the impact the cryptocurrency has in a matter of changing our usage of money. So I don't know if it's better to use cryptocurrencies or real money in terms of climate change. Nonetheless, there have been a lot of other type of research done on the way we farm those cryptocurrencies. Those cryptocurrencies relies on paradigms that may be different. So the Bitcoin, for instance, relies on the fact that you have to farm it. So it's proof of work. You have to prove that you work to get an extra Bitcoin, which is different from other cryptocurrencies that rely on the proof to store, I guess. So you don't farm, you just store some information and let other people store in your computer. But as for the one that are more of a proof of work paradigm and that are using the data center you're mentioning, does it matter? Yes, it matters a lot. I don't remember, but like if Bitcoin was a country, it would be like top 15 or top 20 in the one using the most electricity. However, if you remember well, electricity is not energy. Those are different things. So once you know that it's using a lot of electricity, a good question is, where does it use electricity? And the fact is that it uses electricity where it's the cheaper. And where it's the cheaper, the electricity is cheaper where work labor is cheap, but where also the production is cheap. And this happens mostly in two countries, China and Iceland. Because China, not everywhere in China, but the energy grid of China is not connected between all the regions. You have different grids in China. There are some regions in China where there's more energy production than consumption, thanks to their hydropower. And so in this area, the electricity is very cheap because they want people to use the electricity they are basically delivering for nothing. So in these regions, but also in Iceland, where there's a lot of hydropower, the electricity is very cheap, and they're asking people to use data centers. So in those countries, you can say that it's very cheap, and it's based on hydropower. So it has no direct impact in that sense. Nonetheless, using an electricity that in this way is not a good thing. Maybe you want more interesting things to be computed in Iceland and in China rather than Bitcoin. So this is a very complex question. My point of view is that it's okay. It's not, cryptocurrencies are not using that much of electricity, and the electricity that is produced is usually in countries where there's a lot of renewable, mainly hydropower, so China and Iceland. Nonetheless, I'd better have other type of usage using this electricity rather than Bitcoin. And so if you think about electricity and energy in terms of not of individual but difference in usages, maybe you want a usage that is done in India where electricity is done thanks to coal to be done in China or in Iceland where it's hydropower. Thanks for preparing this presentation, which is undeniably outside the scope of this summer school. So first, I hope you are not disappointed, as it was said, and thanks again for the organizers and to Alexei to let me do this presentation. It has to be casual, but he allowed me to do it more within the program. So I hope you enjoyed it. And so, however, let's turn it around and discuss brainstorm how data science could actually help to fight climate change problems. Yeah, well, let's do that. I'll definitely agree. If you're interested, we can launch a Zoom meeting for everyone to participate. I'll send you, I'll write it down. There's a paper that was written by Yoshua Bengio, but other colleagues. It was not written by Bengio, but he's one of the authors. It's like how climate change can tackle, how machine learning can tackle climate change. And it's not a real scientific paper per se, but it looks at all the different infrastructures and organizations and services and economic domains, and how climate change can tackle some of them, either from a research point of view, from an application point of view, from a business point of view. And they're even saying, stating at the beginning of their of the paper that some are business ideas that you may want to develop for the future. I'll send you the link. And it's actually quite interesting. It's very broad. Another thing I'll add on, I think about Bengio, so all the GAFA, even though he's not part of them. An intellectual defense mechanism you should have is the one you should have when you see that someone, a company basically says that it's carbon neutral. For instance, Apple and Google has said that they are, or they will be, I don't remember, carbon free now or within 2 or 3 next year. And they're saying that because they're using some energy, and so they emit some CO2. And they say that they've bought somewhere, so they are actually buying somewhere credits that say that this amount of energy was exactly produced somewhere else in the planet thanks to renewable energy. So they're saying the amount that they emit, they will compensate it by paying something somewhere, which is, well, it's actually very cool to do, but it's not exactly neutral. Their emissions are not equal to zero. They're emitting some and they're compensating. But if I was a country, and let's say I would emit 2 times as many CO2 as there is emitted right now, and I say, okay, I'll compensate it at the same amount, you see what the problem is. The climate doesn't really care how it's done. So when you say that you're carbon neutral, you better say what you emit and how you compensate it. It's a very long discussion, and if you're interested, I'll can send you some documentation as well. What's your estimate of how long we'll be able to support current way of life until civilization collapse as we know it, given we won't meet our objective of zero emission and go on polluting? 50 years, 100 years? This is a tough one. This is a tough one. I don't know. I want to be in that game of there's so many people trying to estimate when we're like collapse. There's the trend of collapsology. It's interesting to think about it, but I don't think this is an endpoint. It should be a metric of what we're doing. So supporting our current way of life, not much. I don't believe much. There are a few countries around the world that already saw their political democracy failed or even have wars. For instance, Syria has a very important climatic reason to be at war. There has been some drafts just before the war, so people from the countryside went into cities because they were starving in the countryside. And once they get into city, they were facing people from different religion. And once they get like too many person in the same town or same city with different religions and not enough food, well, you see that it starts some problems. And this is one of the problems that started the Syrian war. Venezuela has a very complex problem with the amount of petrol it's able to produce, basically because their money is indexed on the amount of oil they're producing, and as they're producing less, they're having less money. So this is how you go. Sudan had the same problems. Egypt raised their taxes on oil. Well, I'm not saying that climate is responsible for all of these problems, but climate is stressing a lot of problems everywhere around the world. It's already on March. So I would say that we are already changing our current way of life. You probably know that South Africa has a 0 day, which is the day where there's no water at home. So people don't have water at home. There's no more water. So people are running out of water. In India, there has been people dying due to water shortage. So I think that it's already happening, not everywhere. And the fact is that our way of life, like in civilized, like in more developed countries, we're more protected than in poorer countries to face climate change. So I don't know. What's your opinion on the paper that connects IQ levels with level of CO2 in atmosphere? Well, what's your opinion on the paper that connects number of Nobel Prizes per capita to the amount of chocolate eaten This is a real question. Yeah, this is a real paper. Correlation is not causation, or it's just correlation. So I see many ways that IQ may be related to CO2 in the atmosphere based on different factors. So, but I'll look at that, but it seems odd. I've heard that nuclear fission is the cleanest energy source right now. Is it true? If it is, any idea on how to stop people from fearing it? I don't. People don't fear fission. Oh yeah, okay. Fission. Sorry. Yes, it's the cleanest source of energy. But if you think about climate change, it has. So if you look, I'll send you also the link. It's the CO2 emission per kilowatt hour of energy, and the highest one are the highest one is coal, followed by oil, then gas, and all the other one are in the very, very small, like 100 or 1,000 times smaller. Why are people fearing it? Well, it's a very good question. So how to stop making people fearing it? So the causes of this fear, to me, are at least twofold. The first one is that the people that started to fight nuclear energy were people that were fighting war nuclear energy, so bombs. And it turns out that this energy was this war energy was used also for in civilian way, and but people kept on fearing the war part, which is a correct fear to have, I guess. But how to make people stop fearing it? To tell the truth, I mean, it's true. I mean, nuclear is also a compromise. It has some drawbacks, but as for climate change, it's impossible to say that it's worse than fossil fuels. It's way better, like some order of magnitude. So if you disagree with nuclear, if you want to fight climate change and you disagree with nuclear power, then your only option is not to use any energy at all. Otherwise, if you are a climate change believer, but you think that it's nuclear is not good, then you have to provide your arguments on how to do differently the energy. And as for now, I don't know any argument to do that. What are your thoughts on smart grid technology? Those are good ideas, but they face the rebound effect that I've talked about. And the rebound effect is that when you make some optimization on the performance, on the energetic or electric performance of anything, in total, you make this performance realized in a lot of countries. So if we have a smart grid city, I don't know, somewhere in China or in Saudi Arabia, as they're doing it right now, we might want to do it as well in France, in Chicago, in Brazil, and everywhere. And so the problem is that we'll have a lot of smart grid energy cities around the world that will use way more energy than not smart grid energy cities. And this question is very hard to answer because there are very, very, very different type of smart grid energy that are not focusing on the same thing. Some are not focusing on reducing our energy emission, our energy usage, which is to me the most important thing to do. What are the most compelling argument against climate change denials who claim that artificial intelligence is negligible? I'm not sure I understand the question. I don't know how you relate climate change, who state that impact for human activity. Okay. Well, okay, I love this question. Stromboli low. Trombolini low. Let me check that. Brandolini, sorry. So let me find that out. So the Brandolini law, which is called also the bullshit asymmetry principle, states, I find it very interesting, the amount of energy, I mean, as a person, the amount of energy needed to refute bullshit is an order of magnitude bigger than to produce it. And this is actually the type of relation there is between a climate change denial and someone that argues in favor of climate change, is that the climate change denial is just state a fact, a sentence that takes an hour to debunk. And so if you're in this situation, make the situation the opposite. Tell something to the denier that he has to refute rather than do it the opposite. So, and if he doesn't want to do that, well, he's stating something, be as dumb as he or she is,